Good day, everyone. Welcome to Mathematics is Fun class. And today, by the grace of God, we shall be talking about number base. And then, looking at the board, we have some special bases on the board. I mean, those bases that have other name that we call them. Base 2 is known to be binary. Base 8 is known to be octal. Base 10 is known to be denary. So sometimes they can ask you to convert a number from denary to octal. What they are saying is that they are asking you to convert a number from base 10 to base 8. And sometimes they can ask you to convert a number from denary to binary. What they are asking you to do is to convert a number from base 10 to base 2. So I want to quickly tell you something. Please pay attention. Apart from base 10, all other bases follow the same shape. I mean, if you are converting to any other base apart from base 10, they follow the same process or the same shape. Now, let's quickly start. Examples now. Examples. 1. Convert 4 base 10 to base 2. Now, if you want to solve this solution, what you need to do is to prepare a very simple table like this, 3-column table. And what you have there, you have the number you are converting in the middle, remainder at this place. Then where you are converting to base 2, you put that one at the first. Then we start by saying, how many 2 can we see in 114? Are you paying attention? How many 2 can you see in 114? This is very simple. Instead of you racking your brain, you can start by saying, how many 2 can you see in 11? That's 5. How many 2? That's remainder 1. How many 2 can you see in 14? That's 7. Remainder 0. Are we together? Then you put 2 here again. How many 2 can you see in 57? Very simple. You can start with 5. How many 2 can you see in 5? That's 2. How many 2 can you see in 17? That is 8. Remainder 1. How many 2 can you see in 28? That is 14. Remainder 0. How many 2 can you see in 14? 7. Remainder 0. You put 2 again. How many 2 can you see in 7? 3. Remainder 1. Then you put 2 again. How many 2 can you see in 3? That is 1. Remainder 1. Then you proceed. You put 2 again. How many 2 can you see in 1? That is impossible. You put 0. Please listen keenly. The moment you get 0 in this place or in this middle, then the number that you have before that 0 will be transferred to this place. So the moment you have 0 here, the number you have before that 0 will be transferred here, which is 1. Then the number base, you count your answer from down to up. You can see my arrow. Then you have, therefore, 114 base 10 equals 111 0 0 1 0 base 2. That's the final answer. Is that taken? Please, if you don't get it, you can pause the video and rewind it in order for you to get the details. Alright, let's put another question on the board. That's our question 2. Convert 6, which is known to be 16 base 10, into a number in binary. Into a number in binary. So you know what binary is all about. What's that? Base 2. God bless you. So we have our table being prepared. Then what do we have there? You put your 16 in the middle, your remainder here, and then the number you are converting to, which is 2. Then 2 in 16, 8. Remainder what? 0. You put 2 again. 2 in 8, 4. Remainder what? 0. 2 again. How many 2 can you see in 4? 2. Remainder 0. You put 2 again. How many 2 can you see in 2? 1. Remainder what? 0. You put 2 again. How many 2 can you see in 1? That is 0. Then whatever you add before the 0 will be transferred until you get 0 here. Never stop putting 2 here. I take it again. Until you get 0 here, never stop putting the 2 here. Please take note of that. Then know a number base we count from down to up. Then we have therefore 16 base 10 equals 1 0 0 0 0 base 2. That's all. Please, I will advise you to always write your base in word. Always write your base in word. Now, example 3. Convert 74 base 10 into a number in base 3. Base 3. Now, when you want to convert this, please pay attention. Look at what you are converting to. That's base 3. Now, the moment you have that solution, write your solution. So, what am I saying? We have solution on the board. Then we have our number. Then we are converting 74. We have remainder. Then we have about 3 here because we are converting to base 3. Then how many 3 can you see in 74? I've told you before, don't stress your brain more than necessary. How many 3 can you see in 7? 2. Do you understand? Then it remains 1. You put the 1 before 4. Then that is in 14. How many 3 can you see in 14? So that's very simple. That's 4. Then remainder what? 2. Are we together? Then we proceed by saying 3 again. How many 3 can you say in 24? That is 8. Remainder what? 0. You put 3 again. How many 3 can you say in 8? 2. Remainder 2. Then you put 3 again. How many 3 can you say in 2? Impossible. Then what do? You write your 0. Do you understand? Once that particular number cannot go in the number you are talking about, then have your 0. The moment you have your 0, don't forget what I told you. Then the number you have before that 0 will be transferred here. You have your 2 because that's the number we have before 0. And I told you something earlier that the moment you have 0 here, then don't put any other number here. The process has come to an end here. Then you count your answer from down to up. We have therefore we have 74, which is 74 base 10 equals 2202 base 3. I need to tell you this. Please, when you are working under number base, you can never get a number equivalent to the base or greater than the base. Please take note. You will understand this better by the time we are doing addition and subtraction of number base. When you are working under number base, take note. You can never get a number equivalent to the base or greater than the base. For example, if you are working on base 3, the highest number you must see is 2. That is, we see 102. You can never see 3, you can never see 4 when you are working under base 3. And when you are working under base 2, you can never see 2 in your final answer. You can never see number greater than 2 in your final answer. Now, look at this example. That's the next example on the board. Convert 64 base 10 to octa. Very simple. Now, you know what octa is all about. Octa is base 8. Then, solution. Then, you have your table, the number you are converting, your remainder, and where you are converting to. How many 8 can you see in 64? That is 8. Remainder what? 0. You put 8 again. How many 8 can you see in 8? 1. Remainder 0. You put 8 again. How many 8 can you see in 1? Impossible. What do? You put 0 here. Then whatever you have before that 0, you put it here. Then you have, therefore, don't forget to count your answer from down to up. you have 64 base 10, 64 base 10 equals 100 base 8. That's all. Do you understand that? So please take note as we are wrapping it up here before we go to base 10. So please take note of that. Now let me quickly tell you one secret, and I'm going to use this last example to do that. If you are converting a number, let's say you are converting 64 to base 8, by the time they ask you to convert that answer that you have back to base 10, you must have the same answer. Then let's try that with this. Now we are going to base 10 now. Let me write that as a subheading, base 10. Are we together? Now we are having convert 100 base 8 into a number in base 10. Then to solve this, the first thing you need to do is to bring out the number. So you are having 100 base 8. Are we together? Then please pay attention here. You number it from the back. Are you listening to what I'm saying now? You number it from the right to the left. Then you start from 0, 0, 1, 2. Then what do? 1 times the base raised to power what that one is carrying. 0 times the base raised to power what that 0 is carrying. 0 times the base raised to power what that 0 is carrying. Then we have 1 times 8 raised to power 2 plus 0 times 8 raised to power 1 plus 0 times 8 raised to power 0. Then what's the next thing? We have 1 times 8 raised to power 2 is 64. That is 8 times 8 plus 0 times 8, and then we have plus 0 times 1. Anything raised to power 0 is 1. Then we have 1 times 64, 64. 0 times 8, 0. 0 times 1, 0. Then this equals what? 64. Base what? Base 10. Now look at it. That is what I was telling you the other time. Look at it now. When we convert 64 base 10 to base 8, we have 100. So now we return it to base 10. When we convert, what is it called? 100 base 8 to base 10, we have our 64. So that's another way to check your answer in examination, or in order for you to know maybe what you have done is correct or not. Now I want to introduce you to one of the challenge under this number base. Please pay attention. One of the challenges that we have in number base is this. By the time they ask you to convert a number from ordinary base to another ordinary base, what do? Take for instance, this is another example. Let's make this to be example 6. Convert 112 base 3 into a number in base 5. Now look at this. Once you have something like this, what you need to do first is to convert the number given to you to base 10. Then after you might have converted it to base 10, then you now convert whatever you get, then you convert it to base 5. Look at what I'm saying. Then you first convert 112 base 3. Are you paying attention? Into a number in base 10. Then let's go 0, 1, 2. Then what do we have? Then we have 1 times 3 raised to power 2 plus 1 times 3 raised to power 1 plus 2 times 3 raised to power 0. Then we now have 1 times 3 raised to power 2 is what? 9. That's 3 times 3. Then we have 1 times 3 plus 2 times 1. Then we have 1 times 9, 9. Plus 1 times 3, 3. plus 2 times 1, 2. Then we move by saying 9 plus 3, that's 12. 12 plus 2, 14, base 10. Now, convert 14 base 10 into a number in base 5. Are we together? Then you have something like this. We have 14, we have remainder, we have 5. How many 5 can you say in 14? 2. Remainder what? 4. Good. You put 5 again. How many 5 can you say in 2? That is 0. That's not possible. What do? You now carry the remaining one, as in the number you have here before 0, you transfer it here. Do you understand that now? Then draw your arrow. Are we paying attention? Then we have our final answer here. Therefore, what is the number? 112 base 3 equals 24, which is 24 base 5. So please don't forget, this is our final answer. Please don't forget, the moment you are converting from ordinary number to another ordinary number, first take that first ordinary number to base 10 before you now go to the base they ask you to convert to. Is that taken? God bless you. So that's very clear. Then we are moving to addition and subtraction of number base very quickly.